I'd like to welcome everybody back to part two of my series on how to quickly identify fossil woods from this part of Texas. In this part, I'm going to cover monocots, such as bamboo and palm trees, and also ferns, which we do have fossilized in the state of Texas. Okay, so now we need to define two types of angiosperms or flowering plants, the monocots and the dicots. Really what this refers to is the number of embryonic leaves in a seed. A dicot has two and a monocot has one. And where this name comes from is these embryonic seeds are called cotyledons. So this term is usually shortened to monocot, meaning one, and dicot meaning two. There are several very common types of plants that are monocots in the world today. The most common that everyone's familiar with are grasses. And these are similar to grains, which are also monocots in that they're long and narrow and they grow in clumps. There's also bamboo here, and also bromeliads, such as a pineapple, and epiphytes, such as orchids. Epiphytes are plants that grow in clusters up in tree limbs, and they survive on water, actually. The one that we're most interested in is palms. So that's what we're going to talk about today. So first, notice that from all of these types of trees that I just described, their leaves are long and narrow versus the broad leaf of the dicot, which is the most common tree, angiosperm flowering tree that we are familiar with. So since this is a wood anatomy exercise, we're going to concentrate in this level right here about the stellar anatomy of these trees. The primary wood anatomy difference of a monocot is stated right here. Monocots lack cambium. So let's refresh what a cambium is. Cambium is the layer that exists at the outer portion of a tree, inside of the bark, but outside of the inner portion, which is the secondary xylem. And remember, the purpose of cambium is for cell division. It's to grow new cells. And so what it's saying here is that there's no secondary growth, meaning there's no growth of cells of the secondary xylem. So that means monocots have to grow some other way. And so it says here they grow by division and enlargement of parenchyma cells. So what do I mean by that? Let's look at this. So this picture over here is a dicot, and so the cambium is on the outer side. And in a typical dicot, the vessels are scattered various ways through the stem. But in a monocot, the vessels are not scattered around. They are all concentrated inside of these dark circles here. These are called vascular bundles, and they contain one to many vessels inside the bundle. And so vessels only occur in these vascular bundles. Now the vascular bundles themselves are scattered throughout the stem. And what this is referring to over here about parenchyma cells is that all these other surrounding cells here, these are all parenchyma cells in the remaining portion of the stem. And these parenchyma cells themselves will divide, and they will also grow in diameter. They will enlarge. So that's how a monocot grows, which is completely different than how a dicot grows. So here we have a very interesting specimen. You can see this specimen is a cylindrical, it's a trunk actually, very round, and the holes on the exterior they're from water erosion. Water seeking out the weakest places in the trunk to wear away, and so that's, in this particular specimen, they were little circular things. And as I go to the top, you can see this specimen looks nothing like any of the previous specimens that we've been looking at. Right? So this has just a bunch of round dots that make up the entire section. So you see no growth rings, you see no rays, you see nothing except these dots. So let's get in a little bit closer, about as close as we can get with this camera. And you can see those dots are all discrete. You can't really see at this magnification them containing anything, but if I were to get my hand lens out, you would see that they do contain something. So each of those dots is a vascular bundle that contains vessels that carry water. And so this is the typical trunk configuration, vascular configuration of a monocot that has no cambium, and it just is composed of vascular bundles throughout the entire core of the stem. So that is a palm. Here we have another interesting round cylindrical specimen. It looks pretty much like the first one, actually. So you can see on the outside it contains all of these tube-like things which look very much like this previous specimen that I showed. And now as we come on to the top, you see this whole top is very, very pretty. This dark tan outer portion is mineralization with an inner core that did not have as much mineralization in it, which creates this very pretty banding effect. And if we get closer, you can already see those vascular bundles. But unlike the previous one, as we get closer to these, you can start seeing things inside of those vascular bundles. You see these like dots inside the vascular bundles. That is the typical appearance of a palm vascular bundle. So what is happening is the darker places on the corners of the vascular bundles are 2 or 3 vessels that are clumped together there, and the rest of it is parenchyma cells on the outside of the vascular bundle. So that is a typical appearance of a palm stem and of palm vascular bundles. Okay, so for our final illustration of the types of fossil woods you find in Texas, we're going to leave the angiosperms or flowering trees entirely and go to the fern world, which these are more primitive types of trees or plants than angiosperms and conifers. And our example here is of the order known as tree fern, and that is the Cyatheaceae family. And I have a couple of pictures here of what a Cyathea looks like. And this here is me looking up. This is in New Zealand, and I took these pictures when I was there. These are roots coming down the outside of this tree. This tree is probably 15, 20 feet high, with a broad canopy of fern leaves at the top of it. You can see another one over here. This whole forest here is full of these things. This is what the leaves look like, typical fern leaf, but this is known as a silver fern. This is a Cyathea deobata, and it is endemic to New Zealand, and you'll find the silver fern emblem all over the New Zealand and their rugby team, everything. And they get that silver because if you take this leaf, this is looking down the leaf, if you flip it over, it has a silver undersides. So since this is wood anatomy, we need to focus on what the stems look like of these cyatheas. So this is a cross section. You'll notice this looks completely different than what we've seen before. The interior here is mostly parenchyma cells, and these structures on the outside are all what's called leaf traces. Each of these branches, known as this is a branch. People refer to them as leaves. Have a structure of leaves on the branch, but each one of those branches has one of these things right here. So these travel up the stem and then exit at some point from the stem. And so this patterning is what we'll look for in our fossil representatives. Okay, here we have a selection of smallish looking stems, but these all are tree ferns. They are tree ferns of the Cyatheaceae family, and the name of them is Cyathodendron texana. They occur, as far as anyone knows, only in the central coast of South Texas, say Karnes County, McMullen County, Choke Canyon Reservoir area. But they're very common. A lot of people have collections of these things. So let's look at some of these. So a lot of times, so all the ones you see that I show are round, but not always are they round. Sometimes they're flat, which is very interesting. I'm not sure why that happens. These are leaf traces. That's a branch coming out, that's a branch coming out, branch, branch, branch. So that's the patterning you see on the outside. So let's look at some of these others. So this right here, you can see that the cellular structuring, the patterning right there, that's that same patterning you saw in that picture of the live specimen. This down here is the part that was underneath the ground. This is like the root system and the core of the branch of the stem right there. Sometimes I take these and I lop off the top to see what it looks like inside. And a lot of times it's very pretty. You can see that cellular patterning in there with the black interior. And then the leaf traces on the outside, that's leaf trace, leaf trace. Same thing here, leaf trace, leaf trace. Look inside of that. Very pretty in there. And then another specimen. I lopped off the top of this one, and that's very interesting in there. And the bottom, that one has a brown interior with black around it when you see the cellular structures on the outside of that stem. And then this guy is very interesting because the leaf traces are exposed. They're raised. They're outside of the stem, so they didn't get all eroded off. That's very interesting. And then I sliced this in half and polished it, and you can see a lot of structure there. All of this structuring on the outside, that's all the cellular patterning of these ferns. And those are diagnostic features. That's how you can tell them. And so here we have these are brown, and I show these because, say for instance, right here you can see this wavy line right here, and you can follow this around. Most of these are that's a leaf trace, that's a leaf trace, it's another leaf trace, and then this is another leaf trace. That's the patterning you saw in that live specimen I was showing you. And here you can see the same thing. So you can see all these this is at an incline, whereas this is flat, this is at an incline. So some of these traces are inclined here. but you can see all these patterning clearly around the outside. And then these two beautiful specimens are the same as what you were seeing before. There's the leaf traces on the outside, swirling around the outside of that. And another very beautiful specimen. Can't see too much of the leaf traces there, but that brown, tan, and black contrast is just absolutely beautiful. I'd like to thank everyone for viewing this two-part episode on identifying common types of petrified wood that we find in this part of Texas. I hope that this was informative and that you learned something and now are able to go out into the field and look at pieces of petrified wood that you find, hopefully with a 10x hand lens. Remember, that's required equipment for going out into the field. And then being able to identify what you find. So just to let everyone know, as I did in the first part of this series, the second part, I have a reference. And this reference is Common Fossil Plants of Western North America by William or Bill Tidwell. And the two specimens that I talked about here, which is palm and the fern, Cyathodendron, these are identified in this book by Bill Tidwell. And also, again, just emphasizing, if you would like to know anything more about the fossil woods that you find, or would like to learn more about identifying fossil woods, don't hesitate to contact me. So thank you very much, and have a nice evening.